Okay,
Good to
hi
go. Thank you.
everyone. So wherever you are, I hope that you're having a good day. So I'm Nasrin. Today I'm going to talk about how far we've come in giving our NLU systems common sense. I am right now co-founder of Vernic, which is an early stage deep tech AI startup based in New York City. As Rahim mentioned, our mission is to enable anyone to make data-informed decisions, and we are hiring across all sorts of roles. We are in a stealth mode, so unfortunately, I can't really talk about what we are doing today. So I'm going to talk about common sense reasoning, which is hopefully even better. So I thought I open this talk as I usually do and talk about how far we've come in AI in two different realms of it. The first being robotics. So I personally started my work in AI by, working in RoboCop competitions, and back like 15 years ago or so, this was truly the state of the art, and all these like floppy robots that will not be able to basically hold themselves up even. And then I got into natural language understanding because at the same time I came across this motivating classical example of how hard natural language understanding is. And it was through this very, very simplistic sort of prompt that for a sentence like the monkey ate the banana because it was hungry, in order for an AI system to actually do core reference resolution and know that it actually refers back to the monkey, not the banana, it needs to have all this wide common sense knowledge and word knowledge about how the world works and the attributes of different things. So it's a truly, at the time, so-called AI complete problem, and hence much harder than, say, robotics, which is what I was working on. And fast forward, now we are in 2021. I always find the Boston Dynamics videos quite engaging and fascinating. And they have all these capabilities like of doing things. Even they had this really fascinating synchronized dancing that came out earlier this year. And believe it or not, when you feed in that very classical example that I mentioned from years and years ago to the Stanford Core NLP, which is basically the core reference solver that people use in our community, it still gets the reference to it wrong. And this is just to say how hard natural language understanding is in and of itself as a subfield in AI, and how far we yet have to go for making a true progress. So, despite how hard NLU is, there has been a major paradigm shift, which started in 2015. And in 2015 up to 2017, what happened was that a new state of the art got established on various natural language understanding benchmarks. And the recipe was to basically encode the input text using BiLSTMs and then decode with attention, which Chris Manning used to call the BiLSTM hegemony. But this whole recipe had some shortcomings, which personally I was really interested in. And that was the fact that it couldn't really tackle natural language understanding and machine reading and reading comprehension tasks that did require vast amount of background knowledge, common sense knowledge, or some sort of reasoning going from point A to point B with like connecting the dots, and it had long established context, which is why around 2016, we saw a renewed interest in common sense reasoning, with many people in the community acknowledging it as the holy grail of AI. And this is one of the reasons that it was timely for me to introduce story close test, which is this narrative comprehension benchmark, which goes as follows. So the context is, for example, this is what the AI system is supposed to be reading. Jim found an old disposable camera in the bottom of his junk drawer. He began snapping away at everything around him. The counter clicked down to one final photo. The gravity of the situation began to dawn on Jim. And then the AI system's task is to choose between the two alternative endings, one of which is supposedly the correct ending to this very short story. Here, the two alternative endings are as follows. Jim took time to decide what he would take a picture of, and the second being that Jim took 20 more photos. And of course, as human beings, with all the background knowledge and common sense reasoning that we have, it's so easy for us to connect the dots and know that the first alternative is actually the correct ending to the story. But at the time, back in 2016, when we introduced the task, this was a pretty challenging reasoning task where state of the art was about 65% for many, many months after the release of the data set. And again, I want to highlight that the reason we even started working in this and introduced this to the community was to push common sense reasoning forward, because we believe that's what these new sort of deep learning models are not capable of handling. And very much because of that, we decided to actually intentionally not to provide a large direct supervision training data either. As I mentioned, because the goal was to push reasoning forward, and we could see that these existing models are really good at pattern recognition and memorization tasks. So we wanted to make sure that they don't memorize things and they basically will find ways of going off on the wild and trying to elicit knowledge and then bring it to this task and basically use it. Fast forward in 2018, the GPT-1 model, the famous GPT series, like the saga, GPT-1 came out. They actually were making a significant amount of progress on actually establishing state of the art on the story close test, which is also called Raku Stories here. So it was getting 86.5%. Just by fine-tuning basically on our 1,500 data points and being, of course, pre-trained on a very, very large corpus. So the question that we had was, are these models actually showing natural language understanding and common sense reasoning? Are they actually learning to transfer all these sorts of lexical and conceptual and word knowledge to these downstream tasks? So in order to shed some more light on that, we wanted to get rid of some stylistic biases that existed in our own story close test set, which could basically give it away to the model without doing any sort of reasoning. So basically there was some prior work, Martin Sapp at UW and others had figured out that there are some length biases in the two alternative endings, and there's some like different kind of nouns and verbs and adjectives that get used in one versus other. So anyways, long story short, the idea was that we wanted to come up with a new version. We did come up with a new version of a story close test. And to our surprise, after testing all sorts of models and baselines on this story close test version 1.5, GPT-1 was the only model that ended up holding its rather high performance, which was pretty interesting. At this point, we could feel like, oh, well, maybe it is actually doing some common sense reasoning. Fast forward 2020, basically our year of the pandemic, GPT-3 got released. And, you probably saw all the hyped up articles that were written about it. GPT-3 was really doing a fascinating job in natural language generation. So there was even this Guardian article that was supposedly written fully by GPT-3, but of course it was very much handheld. But anyways, a lot of people have been asking me, as someone that has worked on common sense reasoning, how I feel about all of these gigantic language models that are basically performing zero shot on rather challenging tasks. And here GPT-3 actually zero shot was doing on a story close test, basically 83.2. And what this means is that without any fine tuning, even on basically on the 1,500 data points that we had, with just only a sample of those, like handful of samples, is learning to get to very, very interesting accuracy. And the question is, okay, what does this entail for the whole community? What does this mean for AI and our progress in natural language understanding and common sense reasoning? And my answer is that we have come a very long way, and this is definitely progress. This is definitely a small step forward. And yes, truly, this is what having some level of natural language understanding and common sense reasoning looks like. But we have to keep moving the goalpost. back in 2016. I believe that predicting what happens next in a short story is a great benchmark for common sense. But the truth is, well, we can say that that's now gotten to a point that is doable by the existing models, and we just have to keep moving the landmark. So we've come quite a long way in the past few years in giving our systems a bit of this kind of understanding, and this is an exciting progress, but we have to still work on tackling a few issues that these models are truly still grappling with. To give you an example, I basically call these models brutal, like it was a thing to kind of call the prior old school rule-based AI models brittle, but the truth is that our neural models are also kind of brittle because we don't have control and they make glaringly stupid mistakes, which makes them really hard to be deployed in real world, which is what I'm personally interested in. So to give you an example, that same story that I presented, the Jim having a disposable camera, when I would feed that into GPT-3 model to continue, it will basically go on babbling. So it goes, I'm not going to be able to get more film, I'm not going to be able to get more food, I'm not going to be able to get more, ... and a bunch of other nonsensical things, which of course you can try so hard and try to rationalize why this actually makes sense. But anyways, in another version of that, like another kind of a input prompt, somehow it just starts off even generating in a different language, God knows, because of what like character that it has sort of seen in this context. So there's truly no control. And another point I want to make quickly is that, as I mentioned, as human beings, we are so good at trying to post-rationalize things. We're so good at trying to rationalize even random or irrelevant content and even deem it creative. So that's partially what is being done with the generations that we see with the GPT-3s of the world. Some other issues that we still have to work on as a community is that we still don't know the implications of establishing state-of-the-art on various benchmarks. Do they really translate into real-world progress? And the truth is that a lot of times it doesn't. As someone that has worked in real-world AI problems for the past couple of years, I can say that it truly doesn't, and that's something we have to work on. The other issue we have is, of course, all the implications of building these gigantic, ever larger models, all the implications it has for like fairness and also for the sake of the planet, where are we going with this whole paradigm? And we yet don't have an AI system that has the common sense of even perhaps a dog, let alone a 5-year-old kid. So we need to move the goalposts on natural language understanding. And I want to very, very quickly just give a basically teaser into another line of work I did for very much doing so, moving the goalpost. So one capability we have as human, even as very, very young children, is that when we read or we listen to something, we can make actually countless implicit common sense inferences that basically shape and form how we understood the narrative that we were being presented with. So this is an example, the Peppa Pig story. So Peppa was riding her bike, a car turned in front of her, Peppa turned her bike sharply, she fell off her bike, and Peppa skinned her knee. And this is a story from Rock Stories. And as we read this, all of us as human beings, we can construct this truly coherent representation of what happened and why, which combines the information from the text with all this background and like common sense and word knowledge that we have. For example, one such coherent mental model that we build is on causality. So when we read that, all of us, we could readily basically build this sequence of causal events that a car turning in front of Peppa is what caused her to turn her bike sharply, which in turn caused Peppa to fall off her bike, which then causes Peppa to skin her knee and then causes her to likely ask for help. So this is an extra level of inference that we do after reading the whole thing. And another one is on characters' different states, such as emotional or location or other states. So for example, we know that Peppa probably went from the state of being happy and cheerful to the state of being in pain and agony after falling. And we know that she was on her bike throughout riding it, and then after falling, she was on the ground. So these are all these implicit inferences that we do. And as human beings, and to this day, we really did not have AI systems that are capable of basically showcasing similar common sense reasoning capabilities. And the reason for that, I would say, is twofold. One being the difficulty we've had in acquiring often implicit common sense knowledge at a scale that we need for all these diverse set of narratives. And the second being the difficulty that we've had in incorporating knowledge into state-of-the-art AI systems. So I did this work back in 2020 called Glucose, which basically addresses both those twofold problems. And it stands for Generalized and Contextual Story Explanations. And basically all the inferences that I mentioned in the Peppa Pig story is what we want the system to do. And Glucose directly addresses all those. So basically Glucose enables an AI system to do all those inferences that I just mentioned in the Peppa Pig as an example. So the task itself goes as follows: given a shorter story, which we call S, and a selected highlighted sentence, which is X, a Glucose task is to capture 10 dimensions of causal explanation that are related to X. And these dimensions are inspired by cognitive psychology, which often cover all these implicit cause and effects of X, which range from all the events, locations, possession, and other attributes. And the unique thing about Glucose is that it encodes common sense knowledge in the form of these semi-structured inference rules, which we call mini theories about the world, which are also grounded in a specific story. And I'll show you one quick example. So as an example, dimension number 3 in Glucose is an enabling location for X. And remember that X is a sentence. I'm not going to go through the models that we had just quickly. The best model that we had trained was this T5 base model that was fine-tuned on our very large Glucose data set that we collected through crowdsourcing, so about 600,000 inference rules that we had collected. And on average, that encoder-decoder model does 2.3 out of 3, and the human does 2.6 out of 3. So it's a pretty good model, but still there's a gap between human and our best model performance. So this is an example input. So Karen made a pan of lasagna. She brought it to the party. No one wanted to eat lasagna. Karen ate it for a week. She became tired of lasagna. The highlighted sentence is Karen made a pan of lasagna. And so now for dimension 3, the task for the AI system is to come up with an enabling location. So one such prediction is this: she was in front of a TV, enables Karen making a pan of lasagna. So this was actually generated by a GPT-2 model, which we did basically constraint decoding on top. But GPT-2 being GPT-2, this is a pretty bland prediction as to what is a location that enables someone to make a pan of lasagna, and we can say it's a bit incorrect. And then our best model actually says Karen is in the kitchen, and that enables her to make a pan of lasagna. And then it even produces the generalized mini theory about the world to go along, which is someone A is in a kitchen, enables that person cooks something A. And then human predicts Karen is in the kitchen, enables Karen made a pan of lasagna, and the generalization is something similar to human, but a little more sophisticated, where the right-hand side is someone A prepares something A that is a dish. So pretty interesting how far the encoder-decoder model that is fine-tuned, T5 model fine-tuned on our very large scale Glucose model is doing, which is just really a tremendous amount of progress. Another example, which I'll just go through super quickly, dimension number 6 asks for an event that X actually causes. So the encoder-decoder model says Karen makes a pan of lasagna, causes enables Karen eats it for a week, which is pretty good. And then, but the human is more precise and says Karen brought it to the party. I'm not going to go through the details, but one quick thing that I thought would be interesting to mention is common sense reasoning sometimes is basically kind of correlated with models hallucinating, like the example of kitchen, right? Who says that Karen was in the kitchen? Maybe she was making a pan of lasagna I don't know, like sitting on her couch, right? It's not impossible. But the thing is that the truth is, even as human beings, we also don't just perceive the world as is. We actively try to make our best guesses based on all the priors we have about how the world works. And that kind of goes to that there are people who would even go as far as saying that our conscious reality as human beings is just a hallucination that we all collectively agreed upon. So the truth is that our AI reasoning systems are also simply making their best guesses, given all the evidence that they've gathered, all the basically perception that they've done, and anything basically is defeasible in light of having collected further information and knowing more about the underlying context. So if Karen was told to be sitting on the couch, let's say, we would not be making that assumption that likely she was making the lasagna in the kitchen. So to conclude everything, we have come a long way in giving our AI systems narrative and natural language understanding in general and common sense reasoning. So maybe we are in the middle of that, the foothills that I've presented, but we really need to go there where the sun is, and we have a long, long way to go. And to conclude, to just finish up, I thought I've liked this Stacey Abrams like little note about causality, and why I personally care about causality is very much in line with this. And it's because jumping from basically what to do is meaningless if you don't know why, which is truly why I think we should teach our AI systems to perform causality. Thank you.